First is uh, this is shows a particle of mass 2m. So this is 2m. They don't even give the kgs, right? So very difficult to calculate is 2m, right? Which moves on a rough surface of a angle sine theta. The sine theta is 3 by 5. You know, if sine theta is 3 by 5, cos theta is 4 by 5. Understood? Okay, now the a second passes 5m and a light inextensible string which passes over the smooth pulley and the other end is attached at A. The coefficient of friction is 3 by 8. So mu is 3 by 8. Now, uh, is initially above the ground and is 4 meters. And when the system is released from rest with string taut, moves with greater flow. So this moves up and this goes down. Now, why does this go down? Because this is moving up because there is a tension, and the same tension is here. Tension is always away from the body, so the arrows are put in the away from the body from the point of contact. It's a pulling force. Tension is not a pushing force. Okay. So now what happens is we come to know that the tension will cause an acceleration. So tension causes an acceleration, and the acceleration causes change in velocity. Now, after the string breaks, when the string breaks, this string breaks here, the tension goes away. Tension goes away. When after the string breaks, there's no tension. But A will change. A will change. What will happen is now A is only G, acceleration due to gravity. Initially, there was both. A and G were both. There was a tension and there was a gravity force, and the resultant was A. Now, once the string breaks, the tension will go away. The A will change. It will only be G now. And of course, friction will be taken care. And then velocity will change. So now we start doing the question. First, it says find the initial acceleration of A. That is when it was taut. So you see there will be a force acting downwards. That will be mg sine theta. So it will be 2m. M is 2m. Mg sine theta. Uh, this force is acting downwards, but this is going upwards. So there is friction also opposite to this. So what's that? That's mu r. And r is mg cos theta. So it is mu mg cos theta. So this is the friction and tension is acting here. So the resultant of all of these is the acceleration. So t minus 2 mg sine theta minus mu mg cos theta is equal to 2 ma. Now this is 2 mg. So because this was m is 2m, 2 ma. This is the first part. As far as this is concerned, this is 5m. So what are the forces acting on it? Force acting is downward. That is causing it the acceleration. So 5 mg minus t is equal to 5 ma. This is the resultant force ma. This is the resultant. These are the forces acting. This causes that. Now if you add these two, t will go away. And then what you will get is you will get acceleration. Acceleration. So of the both the because they are connected, the acceleration is same. So if you add these two, you will get 5 mg minus 2 mg sine theta, which is 3 by 5, minus mu, which is 3 by 8, 2 mg, which is cos theta, which is 4 by 5, is equal to 7 ma. If I add these two, I'll get 7 ma. Now the m's cancel. That's why it was not required. That's why they had given m. And you will get, no, this is going to be 2 into 4 is, this cancels. So this goes away, this goes away. Mg stays. So we got 5g minus 6 by 5g. This is 5g, 6 by 5g minus 3 by 5g is equal to 7a. And that's how you get a. A is, you will have to get, a will come out to be, I'll have to find the LCM of all this. So this is 25g minus 6g minus 3g over 5. That's 25 minus 9g. That's 16g by 5 into 7. So A is 16g by 35. Can you check the answer? Now the string breaks. Okay. The problem is, I told you there will be no tension now. There will be no tension. So that means T will be 0. But the force, what will be the forces acting on? Now he's talking of A only, okay? He's talking of A. But he says it breaks when it has reached 1 meter. Uh, so it's gone down 1 meter, okay? And now I have to find, if I this if it's gone 1 meter down, that means this has come here now 1 meter ahead also, right? So it is nearly at 3 now. It was initially at 4, right? The point is, if this is the acceleration, and it has traveled 1 meter, what is its speed at that moment, at the moment it broke? So that you have to first find. So the speed is v square minus u square is equal to 2as. U was 0 initially when it started, and it has now got a velocity v which has come after 2 into a was 16. What was a? I had written it somewhere. Yeah, 16g by 35. So a is 16g by 35. S is 1 meter. This would give me the velocity of a. So v square is 32g by 35. This is the velocity at this moment when it is here. Okay, because it has gained some speed because of the acceleration. Now what happens is the spring breaks, so the t goes away. So the only forces acting on this are this 2 mg and the friction, and this uh, these forces. But what is he asking me? By using the principle of conservation, I calculate the total distance moved by when before it comes to rest. Okay, we don't have to worry about that. We know this is the velocity. Now I know the I'll have to find the um, final velocity. Okay, so that will be 0 because it comes to rest, right? So this velocity, this kinetic energy converts, it becomes 0. So that means it converts into potential and work done by friction. Work done by friction. So I need to know the basically what happens is the change in kinetic energy is equal to work done by friction plus the increase in potential energy. Okay, he's asking me the total distance traveled. So supposing the total distance is h, supposing it is h, so it will move from here to here. So there will be a gain in the potential energy. So this gain is because if this is h, the and this is this will be h sine theta. So it will be h into sine theta was 3 by 5. This is the height gained, and into mg. That's the potential energy gained. So this is 3 by 5 h mg. This is the potential. And what is the work done by friction? I know the friction. I know h is the distance traveled. I know the frictional force. That's mu mg cos. So this into mu, which is 3 by 8, mu mg to mg cos theta is 4 by 5. 2 mg cos theta into mu. This is equal to uh, half mv square. So this is equal to half mv square, where v is this much energy goes because it becomes 0. So half again cancels, m cancels, ms cancelled. I need h, so half into v square is 32g by 35 is equal to h. I take out the thing g. I've got a g also. So um, I've got this is You can do this 3 by, it was 2, 3 by 8 mu mg into 4 by 5. So this 2 and 4 cancel again. So it is 3 by 40. No, no, this goes away. This goes away. 3 by 5 and 2 into g plus again we had was this 3 by 5 mg 2 mg. This was also 2 mg. This got mass is this 3 by 5 sine theta. Yeah, 2 mg. So again I have got 6 by 5 g. So this is 9 g by 5 into h, and you can then take this to the g cancels. Okay, so I get this is 16 by 35 is equal to h into 9, and h comes out to be uh, about 80 by 35 divided by 9, something like this. Can you just check the answer? 80 by 35 g, something like this will happen. This is 8.96. Actually, that's the same thing as this. I'm using 32. 32. What he should have done is v squared minus u squared is, this is 32, right? So 32 by 35. 32g by 35, and you can, so that would be half. Yeah, uh, this is h. He's taken h instead of x. So I took 2 mg x sine theta, 2 mg h into 3 by 5, 2 mg, 2, yeah, this is what I did, 2 mg h into 3 by 5. Yeah, that's what he also has done. 2 mg h, okay, 3 by 5, and the work done by friction is 3 mg by 5 h into 3 mg by 5 h into the, this is 3 by 5. So what did I say? I said work done is, friction is um, mu mg cos theta into h. So mu is 3 by 8, 2 m into g into, this was 4 over 5 into, he took x. So basically 4 and this cancel. I told you this 3 by 5 mgx. Yeah, that's what he also has done. You see 3 and then the sum of these two, this work done is plus this work done is this. So everything is same. Okay, you just do the calculation, everything is fine. Same.